Alright, boys and girls, welcome back to the drive-thru. This is a remix 10.9 audio version. Is there a blue light on this thing? I think it's 1.9. I think it's 1.9. That's because I'm in chapter 10 in calculus. So it gets confusing. Alright, 1.9 for all my perfectionists out there. Hungry? Stop by the deli. Get a coffee. Just a coffee this morning is all I need from the deli. Black. Alright, so probability is the ratio between the number of favorable outcomes and the total number of outcomes. Or it's winners over total possibilities. You guys are going to have to do these the long way. It's just the best way to do them, okay? Eventually we might be able to talk in the second semester about faster probability rules, but these are just too complex. So we're going to do 3 examples. They're going to get more difficult as we go. If 2 of the 4 points are selected at random, what is the probability that both of them lie on ray CA? Okay? When you do these, you have to think about geometry when you're doing the probability. And I'll explain that right now. But what we're going to do is make an organized list. So we'll start with A and pair it with B. What would be the next sensible pair? AC, and then finally A. Ouch. Okay, AB. So those are all the ways we could pair a point with point A. Now here's where we have to think about geometry. Is selecting BA any different than selecting AB? It is not. So we should not write down BA. So what would be the first point we would pick to pair with B? BC, very good, and BD. And then finally CD. Okay, now we have 6 total options. What is the probability that both lie on CA? So do both these lie on CA? Yes. These 2? Yes. These 2? No. Yes. No. No. 3/6 equals 1/2 or 50%. All of those are good answers. Reduce your fractions, but you can write probability as a fraction or a percentage, or a decimal if you really wish. Okay, if 3 of the 4 points are selected from the same angle, what's the probability that the ordered letters will correctly name the angle shown? Okay, we'll start with what's probably the first set of 3 points that I'll pick. ABC. What would be next? A, B, D. So we're kind of trying to go alphabetically. That's all the ways I can start with A and B. So what should I do next? A, C, B. So here's where you got to think about the geometry. ACB is a different group of letters than ABC because, what are we talking about? Forming an angle. So in this one, what's the vertex of that angle? B. And in this one, what's the vertex? And so that's why you have to rewrite them. Okay? So I'm going to go faster now. What would be next? A, C, D. Now what? Very good. No. Yes. Okay. Is there any more combinations that start with A? No. Okay. So now we'll go B what? Next. Yep. Uh-huh. Yeah. Yep. Awesome. That's good. That's good. Okay. Next. Nope. Yep. 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 Almost done. Dab. Dak. Db. DBC. DCA. I like it. DCB. Okay, so how many total do we have? 24, right? 6 times 4? All right, how many of them, well, what do they need to have as their vertex? C, but we got to be careful. Actually, yeah, as long as they have C. So this one's out. Out. ACB, does that work? No, it doesn't. Right? ACB does not represent that angle. Out. What about ACD? In. Out, 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 out. BCA? No. BCD? Yes. Okay. Out, 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 out. Out, 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 out. DCA? DCB? How many? That's clearly a 6. It's a repeating 6. With a nose. With a nose. Okay, now, I can't tell you how many of you are going to get this wrong on the test, just so you know. Okay? It is so simple. It involves adding and subtracting. That's it. But the problem is people always count points. How many points are on line segment AB?
12.
Infinite. So they always try to count the amount of points that will work. And that takes a long time when you count to infinity. Although my son told me yesterday he could count to infinity by 5s, which is amazing. I mean, literally amazing. Okay. No, you can't count to infinity. All right, so the question says, a point Q is randomly chosen on this segment. What's the probability that it is within 5 units of C? Okay. All you got to do is do some subtraction. Okay? So, 11 minus 5 is what? 6. So anything on the number line it doesn't matter. Because how many points are on that line? There's infinite. And we're doing probability, right? So if I take 1 extra point out of infinity, it won't even affect the overall probability. But if you'd like for me to put an open circle there, I respect your prior knowledge, and I will do that. I will certainly do that. There you go. All right, so how big is this space from here to here? How many units long is that? 5. Okay. Is that all the things that are within 5 units of point C? It is not. There's some on the right as well, are there not? And how long is that pink segment? That is 4. You got to use subtraction, and you can't trust the picture. Okay? So what is our range? How big is our zone that is highlighted of success? 9 units out of 12. So that's 3/4 or 75%. I think I might play this video in class when I give back the test, and you guys do that your own way, and you count points. And you guys are going to get 8/11. Oh, okay, 12, good question. The 12 comes from the length of the entire segment, which is 15 minus 3, which is 12 units. Excellent question, Grace. It would not have been a good video without it.